Hello everyone. In this lesson we look at exponents, order of operations, and introduction to algebraic expressions. First concept is exponents, so you should be familiar with exponential notation. You could read the idea of expanded form. For example, 5 raised to the third power or 5 cubed basically means 3 factors of 5. So you have the 5 represents the base, and the little superscript written to the upper right is the exponent. So you could read the details, but the exponent tells you how many times the base appears in the product. So 5 raised to the third or 5 cubed means 5 times 5 times 5, and you could do that on your calculator or grind it out, and we get 125. So 2 raised to the 7th power. So 2 to the 7th means 7 factors of 2. So count them all out. 1, 2, 3, 4, 5, 6, 7. And then you could just go from left to right. 2 times 2 is 4. So if you take care of these two, rewrite the rest of them. There's 5 more. Take care of these 8 times. Then there's 4 more. Just the long way, obviously. 16. And there's 3 more. 32. And 2 more. And then finally 64 times 2 is 128. There is an exponent key on your calculator you should get familiar with. That is this little arrow symbol, this what we call the caret key. So that represents the exponent, and the way to do this is to type in the base, so 2, and hit the exponent key. So you can see on the display the upward arrow, our caret symbol, and then the exponent of 7, press enter, and it does all the work for us. So here's some exponential properties involving 1, and next key concept, fractional basis. And concerning fractional basis, I like the second approach where we're basically using the property a over b raised, let's say, to the nth power is a raised to the nth over b raised to the nth. That is, you raise numerator and denominator to that power and keep it as a fraction. So using that concept here, you could read either examples and use whatever approach you feel more comfortable with, but I like this one. So we have 1 to the 6th over 2 to the 6th. You just do them separately. Well, 1 to any number is 1. You could do that on your calculator if you need to. And 2 to the 6th, you can count it out. 2, 4, 8, 16, 32, 64. Or use your calculator once again just to show the quick keystrokes. Enter the base of 2. The caret exponent key. Exponent of 6. Press enter. And it does work for us. So 64. So 1 over 64. Okay, the next idea is order of operations. And you might have heard the expression, please excuse my dear Aunt Sally. P stands for parentheses, but really more than that, any type of grouping symbols. Could be parentheses, could be the square brackets, could even be the fancy braces. So the square ones are called brackets, and the fancy ones are braces. So those are all considered grouping symbols. But the P is used to represent the grouping symbols, primarily parentheses. Then we go to exponents, then multiplication, division, addition, and subtraction. Kind of special rules here. They're grouped together for a reason. The reason is, as we mentioned in the details, is that if an expression is reduced to those operations, we perform them as they appear from left to right. So that's an important subtle point. So you could read the example, the pencil problem. I'm going to recopy. We have 8 plus 64 divided by 8 times 4. Okay, I'm going to write down the order of operations. A lot of times people will say PEMDAS or PEMDAS, or they'll say, please excuse my dear Aunt Sally. But with this, I always take the time to group these, as mentioned earlier. Now, there are no parentheses, so we could skip that step. No exponents, but multiplications and divisions. And remember, the idea is the order they appear from left to right. So even though the M comes before the D in the acronym, the hierarchy tells us these two are performed in the order they appear from left to right. Now, your best bet is to recopy everything except the one operation you're doing. And that, in this case, is 64 divided by 8, which is 8. And then recopy times 4. Now, multiplication comes before addition, so 8 plus 32, and finally 40. Okay, so there'll be a bunch of nice examples that you could read over, and I'm just going to go through the pencil problems with you. I'll recopy the question. And that's actually a division there, I believe.